Hi everyone, in today's video we will be looking at expansion of algebraic expressions of the form a plus b multiplying with c plus d. As such, the objective of today's lesson is to learn this. Before we look into that, we will do a very quick recap of the distributive law. Previously in Sec 1, we learned how to expand expressions such as 5 times x plus 3 and negative 4 times 6 minus 3x. In doing this expansion, we apply our distributive law, or in some cases we call it the rainbow method. So, looking at 5 times x plus 3, we know that the distributive law is being done by taking 5 multiplying with x in order to get 5x, and 5 multiplying with 3 or positive 3 to get plus 15. Hence, the expansion of this results in 5x plus 15 as our answer. In the other example, negative 4 times 6 minus 3x, when applying our distributive law, we will take negative 4 multiplying with 6 to get negative 24, and negative 4 multiplying with negative 3x to get positive 12x. Do recall that a negative with a negative will give us a positive. After recalling how the distributive law actually works back in Sec 1, we will now learn how to apply the distributive law to expand expressions such as x plus 2 times x plus 3 and x minus 2 times negative 3 minus x. However, before looking at the application of the distributive law, we must first understand what are the terms found within these expressions itself. So, in x plus 2 times x plus 3, we recognize that within this set of brackets, x is considered a single term. In fact, it is a positive x. And then we have a plus 2. Then in the next pair of brackets, we have a positive x again, and then a plus 3. In the other example or the other expression over here, we recognize the same thing, that the terms found inside the first pair of brackets is positive x, minus 2, and then in the second pair of brackets, we have negative 3 and minus x. So after recognizing the terms found within the brackets, that will help us greatly in applying our distributive law to expand these expressions. Let's take a look at expanding the first expression over here. That is x plus 2 times x plus 3. When applying our distributive law, we will take the first term x found in the first pair of brackets to multiply with the first term found in the second pair of brackets. So x times x results in a x squared. Then we take the first term found in the first pair of brackets to multiply the second term found in the second pair of brackets. And that is taking x to multiply with a positive 3, and that results in a positive 3x. Okay, then we look at the second term found in the first pair of brackets, and that is a plus 2. We will do similarly, okay, from what we done earlier on. Okay, so plus 2, we will multiply with the x, like that, to get a plus 2x, followed by a plus 2 to multiply with a plus 3, and that gives us a plus 6 over here. We know that positive 3x or plus 3x and plus 2x over here, they are considered like terms. We can simplify this expression over here by adding 3x and 2x together, and that will give us the final answer of x squared plus 5x plus 6. So I have demonstrated over here how the distributive law is being used to answer the expansion of expressions such as this. Let's look at another example. Looking at the second example, x minus 2 times minus 3 minus x. Again, we do the same thing. First term in first pair of brackets to multiply with first term in second pair of brackets. And that will result in a negative 3x. Then, first term in the first pair of brackets with the second term in the second pair of brackets. Because this is a positive x, multiplying with a negative x, it actually results in a negative x squared. Okay, this is also the similar reason why earlier on it is a negative 3x. Then we follow it we continue by looking at minus 2 over here, okay, to multiply with minus 3, and that will give us a positive 6, because if you remember, minus and minus gives us a plus. And then we take a minus 2 to multiply with a minus x, and that will give us a plus 2x, because again, minus and minus gives us a plus. Then we recognize that there are again like terms where we have a negative 3x over here as well as a positive 2x. A minus 3x and positive 2x will actually simplify to getting a negative x, or rather negative 1x, which some of you may think that way. So in simplifying this expression over here, our final answer would then become negative x squared minus x plus 6. When doing our distributive law, it is important that we do the arrow signs consistently and in an orderly manner. So I like to have my first term over to the first term, then first term to the second term. Don't do all over the place, because otherwise you will get yourself confused and you will lose count of all these arrows that you are drawing. Whenever you are connecting the two terms together by having the arrows, keep in mind that we are trying to do multiplication. Okay, usually the numbers are simple enough for us to do mental calculation. Otherwise, you may use a calculator to help you in that calculation. We just need to be very clear about what are the things that we are multiplying. Let us now take a look at some examples found from our textbook, page 53, Practice Now 5. I will only be going through the questions part A, C, E, G, and J. I will first start with part A. So looking at part A, we have a plus b times 8x plus 7y. Using what we have learned earlier on about the distributive law, we will take a to multiply by 8x, and that will result in a 8ax. Then we will also take a to multiply, in this case, the positive 7y, and that results in a positive 7ay. Then we do the second term found in the first pair of brackets, that is a positive b multiplying with a 8x, and that will give us an answer of plus 8bx. Then finally we will take plus b to multiply with plus 7y, and that would actually give us plus 7by. I hope that after going through several examples so far, you are able to follow how the distributive law actually works. If you don't, let's take a look at part C. In part C, we have 5a plus 2 multiplying with x minus 2y. So look at how my arrows are going to be connected. I first take 5a to multiply by x, which results in 5ax. Then I take 5a to multiply with negative 2y, and that will give me negative 10ay. Next, we move on to the second term found in the first pair of brackets, and that is a positive 2 multiplying with a x, and that will give me plus 2x. And finally, we will take plus 2 with the negative 2y, and that will give us a negative 4y. That's because 2 times 2 gives us 4, and plus and minus gives us a minus. So we need to be very careful about the operations and keep those in mind whenever we are doing our calculations. If you still need another example, let's take a look at part E then. We have x minus 4y multiplying by 2c plus 3d. First, we have x multiplying with 2c, and that results in 2cx, followed by x multiplying with 3d, and that results in a 3dx, a positive 3dx. Then we move on to the second term found in the first pair of brackets, that is a negative 4y multiplying with a 2c, and that results in a negative 8cy. And finally, we will take negative 4y to multiply with positive 3d, and that would give us a negative 12dy. I hope that with these three examples so far, you are getting the hang of it, And perhaps you may want to pause the video over here to give part G and J a try, okay, to test out your concepts before moving on to look at what my answers are. I hope that you have given part G and J a try on your own, although J is a little bit challenging because of the fact that there are 3 terms found in the second pair of brackets. However, the concept to be applied remains the same. But first, let's take a look at part G. We have 6p minus 5q multiplying with 3r minus 4s. So doing our same distributive method or distributive law, we will have 6p multiplying with 3r, which results in a 18pr, and then 6p minus 4s, and that will result in negative 24ps. Then moving on to negative 5q, which is the second term found in the first pair of brackets, we have negative 5q multiplying with 3r, and that will give us a negative 15qr. Lastly, negative 5q with a negative 4s, we will have a positive 20qs. Next, we take a look at part J. We have negative 4r minus 3s multiplying with 3 minus 2t minus 5u. So, in this case, when doing our distributive law, we'll do it individually, starting with negative 4r first, multiplying with 3, and that will give us a negative 12r. Then, negative 4r multiplying with negative 2t, that will give us a positive 8rt, sorry. And then because there are 3 terms found in the second pair of brackets, we need to remember to take negative 4r to multiply also with the negative 5u. So I hope that you have captured the entire idea of your distributive law. We are distributing from one term to the rest, okay, in the next pair of brackets. So in our third pair over here, negative 4r with negative 5u, we will get a positive 20ru. We do the same to negative 3s, and we will be getting negative 9s first, followed by positive 6st, and lastly, positive 15su. Okay, notice that in practice now 5, my answers are left as such. I did not have to simplify it because the terms that we arrive at does not have any like terms. Okay, for example, in part G, this is a PR, this is a PS, this is a QR, and this is a QS. They are all unlike terms, they are different. So therefore, there's no way for us to simplify our answer. We can only do our expansion and stop at there. Likewise, in part J, looking at all the algebraic letters carefully, okay, they are actually all different. So there's no like terms at all. So if we were to go back to the earlier examples, A, C, and E, okay, let me just go back and show you. Okay, all this over here, there are actually no like terms at all. So there is nothing for us to continue simplifying. Alright? And with that, we are done with practice now 5. We will now take a look at practice now 6, which is slightly more complicated because we have multiple things to handle within the expression itself. So looking at part B and D only, in part B we notice that there are actually 2 main components in the expression, which is this first part over here, followed by a minus sign and separated by the separated into the second component, okay, which is this part over here. Likewise, in our part D, we have our first component found here with these 2 pair of brackets, followed by a plus, and then the second component is this 2 pair of brackets over here. Okay, so we need to do things individually. There is no point trying to be fast over here. We always need to learn how to be careful first in order to increase our speed later on. So taking a look at part B, we are given 2x times 3y minus 4z minus 3x plus y times y minus 3z. So as I mentioned, we do things one at a time. So in our first pair of brackets, okay, maybe let me just grab a highlighter. Okay, this is the first pair that we will be looking at. Okay, or rather first component that we will be looking at, sorry. Okay, we will take 2x to multiply by 3y, which is a distributive law method that we have learned in Sec 1. That shouldn't be unfamiliar to you. And that will result in a 6xy. Then we take 2x multiplying with a minus 4z, and that will give us a minus 8xz. Okay, so because there is actually a minus sign, so let me just change my ink color. Okay, there is actually this minus sign over here. Alright, so we need to actually include that minus sign, alright, followed by a pair of brackets. Okay, because what we're going to do is that we are going to be focusing on the expansion of this second component. So we want to keep our mind away from the minus sign that I have circled in green and focus only on the expansion that I have highlighted in yellow as shown over here. Okay, I hope that you can see my laser pointer. So doing our distributive law for this second pair of brackets, or rather second set of brackets, we have 3x multiplying with y, and that will give us 3xy. Then 3x multiplying with negative 3z, and that will give us negative 9xz, followed by plus y with another y, that will give us positive y squared, and then plus y with a negative 3z, which gives us a negative 3yz. So that is done. That is our distributive law being done over here. Okay, so therefore we close our bracket. Then we need to simplify our answer by making sure that we need to open up these brackets, and because there is a minus sign on the outside, it will affect the operation of all the operations found inside the brackets. Hence, in our next step, we will write our 6xy minus 8xz, because that has no change, there is no impact at the front. Okay, followed by minus, and then 3xy plus 9xz minus y squared plus 3yz. So the operations actually change due to the minus sign that we have over here outside the brackets. We always need to remember how to simplify our answer or check for simplification, and we observe that we have some like terms. Okay, so we have 1 6xy over here and 1 minus 3xy, and that will actually result in a 3xy, a positive 3xy in fact. Then we have another set of like terms, which is this minus 8xz over here with the positive 9xz, and that will give us a 1xz, which we need to write it as just plus xz. The remaining terms minus y squared and plus 3yz, okay, they are not like terms at all, so we will just write it, okay, continue writing it in our simplified expression. So therefore, this is our answer to part B. Let us now take a look at practice now 6 part D. So in practice now 6 part D, we are given this expression h plus 6k times 2m minus h plus 3h minus 2m times 2k plus h. So we need to observe again that there are actually two things that we are trying to expand. The first of which is actually this one here. Let me just grab a yellow highlighter. So this is the first thing that we want to expand. Then later on, we will change to expand this part over here. Okay. Alright, so looking at the very first expansion, the yellow one that we have, okay, doing my distributive law, I will have h multiplying with 2m, that will give us 2hm, followed by h multiplying with negative h, that will give us negative h squared. Then positive 6k multiplying with 2m, which results in positive 12mk or 12km. Then positive 6k multiplying with negative h, and that results in negative 6hk. So this is our expansion for the yellow component in the expression. So let me just underline this in yellow. Then, likewise, similar to how we did part B, because there is this operation here, let me just grab a color. We have this operation, there's a plus sign over here. We want to usually leave that out in our expansion first so that it is not confusing. And by leaving out, I mean that we will write plus followed by a set of brackets. Then we continue with our expansion, okay, inside the brackets over here. Okay, so looking at the expansion of the component in green, I will have 3h multiplying with 2k, and that gives us positive 6hk. Then 3h multiplying with h, that will give us plus 3h squared. Then minus 2m multiplying with 2k, that will give us minus 4km or 4mk. Then minus 2m multiplying with h, that will give us a minus 2hm. So with that, we're done with the expansion of the green component, and we remember to actually close the bracket. So once done with this, we will try to simplify by taking into consideration the positive sign now. But because we know that the positive sign doesn't have any impact in terms of changing the operations in this pair of brackets, so therefore, what we will do next is that opening up the brackets will leave us with 6hk plus 3h squared minus 4km minus 2hm. So no change in operations at all. Then we go about simplifying our answer, and we notice that there are actually like terms. So let me grab a color. We see that we have 2hm over here, and we actually have a minus 2hm. So there is actually no more, in fact it is 0 hm's left. Okay, then we also have a minus h squared and a plus 3h squared. So that simplifies to a plus or positive 2h squared. Then we also have some more like terms. We have this positive 12km with this minus 4km, and that simplifies to plus 8km. Then the very last pair of like terms, running out of color, okay, so we have minus 6hk and a plus 6hk, okay, and that becomes 0. And therefore, my most simplified answer would be 2h squared plus 8km. And so with this, we are done with learning how to expand our expressions that are found in the form a plus b multiplied with c plus d. I hope that you are able to understand the examples that I have demonstrated so far. Please continue to practice it to hone your skills. Okay, I'll see you in our next lesson, where there will be a quiz as mentioned previously for me to assess your readiness in your expansion skill. I'll see you in the next lesson. Bye bye.